Now we're going to move on to a new topic, implicit differentiation. Okay, so if you get a graph plotter and plot this line here, y equals 3x plus 2 over 5, it will look like this red line here. Now, if you times both sides by 5, it will give you 5y equals 3x plus 2. Take away 3x from both sides, it will then give you this. Now, you getting a graph plotter and telling it to plot y equals blah 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 here, it gives you this red line. You see, if you get the same graph plotter and tell it to plot this, it will still give you the same red line here. The point is that this is one way of telling the computer how to plot this line, and this here is still a legitimate way of telling the computer how to plot this line. You see, if you select any point on this line here, let's just say this one here. This point here is 2, let's just say 1.6. Let's just say that. So remember that this here is your x value here. This here is your y value here. Now, if you put 2 into the x here, if you put 2 into the x here, and then if you put 1.6 into the y here, this side here will equal this side here. You see, it's still, my point is that this is one way of telling the computer how to plot the graph. This here is still a legitimate way of telling the computer how to plot this line. For example, if you get a graph plotter and punch this into there, and then it will give you this circle here. You see, if you select any point on this line, let's just say this point here, 1, 1. So remember that this here is your x, this here is your y. If you put 1 into the x here, and then put 1 into the y here, this side here will equal this side here. And if you select anywhere, it could be here. So let's just say this is minus 0.5 here. That's your x value there, and y will be, I'm going to guess 1. Hang on, let me think. Well, let's just guess it to be 1.3 or 4. Let's just say it's 3. Now, if you put this into here, and then if you put this into here, then this whole side here will equal this side here. You see, this whole thing here is another way of telling the graph plotter how to plot your graph, because every point on this line here will satisfy this thing here. If you select any point, this point here, if you put it into here and then into here, then this side equals this side here. You see, this is another way of telling the graph plotter how to plot this graph. Now, the weird thing is that if you have the same thing, but then stick an xy in here. So earlier it was this here. Earlier it's this. If you stick plus xy into here, the graph will then look like this. It will then skew towards one side. You see, this is another legitimate way of telling the graph plotter how to plot the graph. Select any point on here. I don't know. Let's just say 1. Let's just say this point here is 1, 1,1.6. Say. If you put this is your x here. Put it into here, and then into here, and then this is your y. Put it into here, and then put it into here. Then this whole side here equals this side here. Select another point anywhere on here. Let's just say this one here. You put the x into here and into here, and the y into here and into here. Then this whole side here will equal this side here. It's just another way of expressing an equation, I guess. Here, if you punch this into your graph plotter, it will give you this weird line here, and this here is another way of communicating with the computer on how to sketch this graph. Okay, because if you select any point on here, let's just say this point here, let's just and then if you put, let's just say this is 0, this point here 0, 1.4. Let's just say that 1.4. You put 0 into here, and then into here, and then you put 1.4 into here and into here. Then this whole side here equals this side here. So whenever you have hang on, let me just move this across like that. So whenever you have an equation where you have y equals blah blah blah, so y is on its own here, and then all the x's on this side here, then this here is an explicit equation here. If you look at this one here, this here is an implicit. It's got a mixture of x's and y's over on this side here. This is an implicit equation here because you've got a mixture of x's and y's over here, and this is an explicit. By the way, sometimes when you're given an explicit one, you can turn it into an explicit one. So here, rearrange this to make y the subject in a way. So you could rearrange this so that would be how y squared equals 3 minus x squared here. We're not done there. And then you square root both sides. So when you square root both sides here, then don't forget you're going to have two versions, a positive version and a negative version. So this one here, now you see, given this here, we can turn into an explicit equation here. This is explicit because you've got y equals this. And then the other one would be y equals minus root, the negative version, 3. So this is also an explicit equation here. This here is an implicit. Okay, hang on, implicit. But sometimes it's so complicated that you can't really turn it into an explicit. Okay. So an explicit is when you have y on its own and then all the other stuff on this side here. An implicit is when you have a mixture of x's and y's floating around. Okay.